I stumbled across some questions and I decided to try them out. So these questions are on product rule. Most of them are on product rule, if not all. Some of them have chain rule intertwined with them, but let's see how it goes. Let's have the first question. So product rule, let me just give you a brief. In the previous video, we talked about product rule and said if y is equal to the product of two functions, ux and v, okay, then the y dx is equal to u dv dx plus v du dx. Okay, let's apply that now in solving these questions. Okay, if you look at this now, look at it, we're multiplying two functions. We're multiplying this and this. So this can be my u and this can be my v. So I can say let u equals to 4x squared minus x and let v equals to t raised by 3 minus 8t squared plus 12. All right, so let's differentiate u in respect to x. This should give me du dx. So du dx here will give me, if these two come to the back and multiply everything, becomes 8x raised power 2 minus 1. That's 1. That'll give me 8x minus differentiate x. This is x raised power 1. So 1 multiply everything becomes 1x raised power 1 minus 1. Okay, which will give me 0. So everything here will give me 1. When you differentiate x raised power 1, you get 1. So this is minus 1. All right. Then dv dx is equals to, differentiate this, you have. So I came across some questions and I decided to try them out. So let's see how it goes. Okay, so here we have this function multiplied by this function. So this is like production because I'm multiplying two different functions. Okay, multiplying this and this. And not the product rule says that if you're multiplying two functions, you use the formula u dv dx plus v du dx. Okay, so let's say this here looks like u, and this here can be what? Can be v. All right, so you say that u is equals to 4x squared minus x, and v is equals to x raised by 3 minus 8x squared plus 12. Okay, so differentiating u in respect to x, so relating this now, that will give me du dx. That should be 8x minus 1. I made a video on the first video on calculus. You can check that out on the playlist to see how to differentiate this. And dv dx will be equals to, I'm going to differentiate this now to give you 3x squared minus 16x plus 0, because when you differentiate a constant, it gives you 0. All right, so applying product rule, we know that dy dx is equals to u dv dx plus v du dx. So that is u in my question. My u is what? 4x squared minus x. And what is dv dx? dv dx is 3x squared minus 16x. So this part now is u dv plus v du dx. What is v? V is x raised by 3 minus 8x raised by 2 plus 12. That is v. Then du dx is 8x minus 1. So this is dy dx. No need to expand. To give us a very, very big algebraic expression. So this is our answer. Let's take a look at the second question. We know that y is equals to, this is x squared cos 3x. Okay, let me bring that down. So y is equals to x squared cos 3x. Again, you can see we're multiplying two functions. So multiplying x squared and 3 and cos 3x. So this is also product rule where u is equals to x squared and v is equals to cos 3x. So differentiating u, that will give me du dx equals to 2x, because when this 2 multiplies and you move 1 from 2, it becomes 2x. Now differentiating v might be a little bit of a problem. I made a previous video on how to solve chain rule in seconds, so I advise to check it out. So this is chain rule where we have a function in another function. So we're having this function 3x in another function, this trig function. Okay, So if you went through the previous video, I explained that the way you differentiate this is first differentiate the inner function. That should give me 3, right? Then differentiate the outer function. When you differentiate cos something, it will give you minus, like when you differentiate cos x, don't forget if y is equals to, then dy dx should be minus sine x. So apply that here. If I'm to differentiate cos this now, that should give me minus sine 3x, assuming that this 3x here is x. So everything here should be equals to minus 3 sine 3x. Okay, now we now know what du dx is and dv dx. Applying product rule, we know that the y dx is equal to u dv dx plus v du dx. So this should give me, what is my u? U is x squared times, what is my dv dx? dv dx, we got it to be minus 3 sine 3x, right? Then plus, what is v? V was going to be cos 3x times, what is du dx? du dx, we got 2x. So multiplying this, we're going to have minus 3x squared sine 3x, okay, plus 2x cos 3x. So this can be the answer, or we can decide to factorize x and have x into brackets minus 3x, because if you take x away from here, you're going to have minus 3x sine 3x, plus take x away from this, you're going to have 2 cos 3x. So this is the final answer. The next question says, again, we're multiplying two functions. We're multiplying this and this. So I can say u is equal to 5e raised to minus 2x, and v is equal to sine 3x. Now we have to differentiate u in respect to x and also differentiate v in respect to x. Looking at these two questions now, looking at these two parts, they are like, this is chain rule because we're having a function. This is an exponential function e. We're having this function minus 2x inside this function. That is an exponential function. That is a composite function or chain rule, function of a function, whatever you call it. So how do we differentiate this? Instead of using the long method and say let this equals that, I did the simple way I explained in the previous video was, I said simply differentiate the inner function. When you differentiate the inner, what's the inner function here in this question? Minus 2x. Differentiate minus 2x, what do you get? Minus 2, right? But we still have our 5, so that's minus 2 times 5. Now differentiate e raised by this. Don't forget, when you differentiate e raised by x, okay, so let's differentiate this now, du dx. Now the main issue now is this part, all right? So that is chain rule, function of a function. So what do we do there? We simply differentiate the inner function, then differentiate the outer function, and multiply our answer. First, let me bring down my 5. My 5 was not having business with this, so let's bring it out. Okay, now let me differentiate the inner function, that is minus 2x. What do you get? You get minus 2, right? Now differentiate the outer function, e. Don't forget, if y is equals to e raised by x, then dy dx is also e raised by x. So I assume that everything here is x. If I differentiate e raised by this now, it should give me e raised by the same thing. That should give me e raised by minus 2x. So everything here should give me minus 10e raised by minus 2x. Hope that's clear. Now for dv dx, again, this is a composite function because we're having this function, 3x, in a trig function, sine. So what do? We differentiate the inner function, and the inner function will give me what? To give me 3. For the 3x and differentiate 3x, you get 3. And differentiate the outer function, which is sine. When you differentiate sine x, it's going to cos x. So we differentiate sine, this should give me cos 3x. So this here should be 3 cos 3x. Now recalling our formula for product rule, dy dx is u dv dx plus v du dx. So let's go. Let's substitute. What is u? My u is 5e raised by minus 2x times, what is dv dx? dv dx is 3 cos 3x plus, what is v? v is sine 3x, and what is du dx? du dx is minus 10 e raised by minus 2x. So simplifying, this will give me 15, because 5 times 3, 15 e raised by minus 2x cos 3x plus, simplify this. Okay, minus times plus should give me minus. This will become minus. So minus 10 e raised to power minus 2x sine 3x. So this can be the answer. Or we can decide to simplify further because e raised to power minus 2x is common in both cases. And also, I think 5 can also go in both cases as well. So I can factorize out 5e raised to power minus 2x. Factorizing this out, what will be left here? 5 in 15 should give me 3. And e raised to power minus 2x, cancel this, you have cos 3x. Minus 5 here should give me 2. And this cancel out that, we have sine 3x. So this is one way of getting our answer.